Okay, ladies and gentlemen, geometry class, this is the spring midterm review, and I'm going over this. This is part 2, problems 16 through 20. 16 through 20. 16 talks about our logic. There we go. It talks about inverse, converse, contrapositive, and is it a biconditional. I'm just going to go through, and I'm not going to write all this down. Okay, so remember, P implies Q. If P, then Q. So if a triangle has all congruent sides and all congruent angles, that's P, then it's scaling. That's Q. So the inverse is just not P implies not Q. So if a triangle does not have all of its sides and all congruent angles, then it is not scaling. Just negate both the hypothesis and the conclusion. Converse, switch them around. Q implies P. I'm just putting them in parentheses for convenience. So, switching it around, it's going to say if a triangle is scaling, then a triangle has all congruent sides and all congruent angles. Contrapositive says negate your converse. So it says if not Q implies not P. So, if a triangle is not scaling, then a triangle does not have all of its congruent sides and all congruent angles. Is it biconditional? Biconditional has to have if and only if. So there's no if and only if, so that's no. Determine if the two triangles are congruent. Well, looking at what I have, I know that all three angles are congruent, AAA. However, and this is, I notice a lot of people mentioning this, AAA is not a congruence theorem. AAA is a similarity theorem. So this says that those two triangles are similar. It's not what I'm asking. I'm asking about congruent. So this is no, they are not congruent. This one, I've got angle, angle, side. That is a congruency theorem. So yes, those two triangles are indeed congruent. And on this one, it's got the same thing. Those are vertical angles, so I've got angle, angle, angle. That is not a congruency statement. That is a similarity statement. Going down here to triangles that are similar, if a triangle is similar, then all of its sides have to have the same ratio. So in that case, this side corresponds to this side, so 9 to 36 needs to equal that ratio. 9 to 36 needs to equal the ratio of this side to this side, 14 over 55. They don't equal. Those are not equal, so that is no, it is not a similar triangle. This one here, in a similar triangle, all of the interior angles have to be congruent, because no matter how the size difference, that those angles are going to be the same. Those two triangles share that angle, so that angle is the same. And then here it says this angle is 41, this angle is 37. Well, those are both corresponding angles. For it to be similar, they would have to be congruent as well. So this one is also no, neither of those triangles are similar. Find the midpoint. Okay, just as a refresher, midpoint formula says the midpoint between any 2 points. The x-coordinate is the x1 plus the x2 of my 2 points divided by 2, and the y1 plus the y2 divided by 2. So there's the midpoint. That being said, x plus the midpoint of this one is 10 plus 5 over 2, and 9 plus 7 over 2. Make sure you simplify. That's going to be 15 halves, comma 16 over 2 is 8. Again, if I don't say exact, you can give me that that's 7.5. I can live with that. If I say exact, I need an exact answer. That's exact. In this case, 7 plus negative 1 over 2 is the x-coordinate. Negative 9 plus negative 3 is the y-coordinate. 7 plus negative 1 is 6 divided by 2 is 3. Negative 9 plus negative 3 is negative 12 divided by 2 is negative 6. There's the midpoint of those 2 points. Midpoint, those 2 points, midpoint, those 2 points. Okay, next section. State the most specific name. Yes, these are all quadrilaterals. They all have 4 sides. However, there are more specific names. In this case, it's a convex quadrilateral. And some teachers make you know the difference between a convex quadrilateral and a concave quadrilateral. So just in case you're looking at this for another class, it's convex. This one has 2 pairs of parallel sides, so this is a parallelogram. Okay, this one has one pair of parallel sides, and the other set is not. So that is a trapezoid. And this one has has one pair of parallel lines and one pair of congruent sides. So this is an isosceles. And I apologize for the spelling. We're just going to say that right there. Trapezoid. Isosceles trapezoid. No, I will not grade you on spelling. Get the idea across. I'll be able to live with that this time around. And that concludes part 2. Questions? Come ask me. Otherwise, enjoy. See you on part